Hello everybody, my name is Erick Francisco Vázquez Alamilla and this poster is titled A Story of the Anodic Electrode in a Sedimentary Electrolysis for Hydrogen Production. Well, electrolyzers are fundamental electrochemical devices for hydrogen production, working by splitting water into oxygen and hydrogen through the application of an electric current. Currently, electrolyzers use proton exchange membranes or anion exchange membranes. One of the main concerns in the operation of exchange membranes cells during prolonged operation is the degradation of the membrane and electrode. Phenomena such as corrosion, passivation, and structural degradation of the electrode are the most significant causes of the degradation. This not only reduces the efficiency of the system, but also shortens its useful life. In addition, over time, a progressive increase in the internal ohmic resistance of a system component is observed. The methodology consisted of 1. Designing and welding the electrolysis cell to connect it directly to power supply. 2. Collecting and storing the gases generated for analysis by gas chromatography. 3. Preparing the working electrode for analysis by X-ray and cycle voltammetry. The results indicate the following. Figure 3A shows a diffraction peak corresponding to a crystalline material whose intensity is greater before the electrolysis process than after, indicating a change in the structure of the material. Figure 3B shows the same phenomenon, although with a variation of laser intensity. In Figure 4A, the oxidation kinase registered a maximum value of 3.5 mA for square centimeter at a potential of 550 mV, while in Figure 4B, the maximum oxidation peak is 2.5 mA for square centimeter at 700 mV, indicating that there are more electroactive species oxidizing in the first graph, as can be seen in the following graphs. There is a direct correlation between current density and the volume of gases generated in the electrolytic cell. Higher current density results in greater gas production. In Figure 5A, current density values were recorded with a maximum of 20.7 mA for square centimeter, a minimum of 7.9 mA for square centimeter, and an average of 50.3 mA for square centimeter, which generated a total of 149 milliliters of gases, of which 78.52% represent the purity content of hydrogen. While in Figure 5B, the maximum value was 8.5 mA for a square centimeter, the minimum was 5.3 mA for a square centimeter, and the average was 8 mA for a square centimeter, generating a total of 62 milliliters of gases, of which 49.3% represents the purity content, the hydrogen. Finally, the conclusion: there are no electrode deposits present. The minerals calcium silicate, silicon dioxide, and sodium chloride belong to marine sediment. The anode with ASM recorded a higher oxidation peak, which resulted in an increase in H production within the cell. It is possible to generate hydrogen through sedimentary electrolysis without the need for an ion exchange membrane using ASM and a sodium chloride solution. Thank you very much for your attention.